Hello, my name is Aaron McNeil, and this video will provide you an overview of Jupyter Notebook and how to use the IDE for writing Python code. Jupyter Notebook is a web application that makes it easy to write and execute Python code directly from the web browser. For this video, I'm going to show you a few basic tips to get you started with Jupyter Notebook. If you'd like to learn more, the link below will take you to the documentation for the Jupyter project. The easiest method to start the Notebook server is by clicking on the Launch button for Jupyter Notebook within Anaconda Navigator. Now, if you do not have Anaconda Navigator installed, our other video installing Jupyter Notebook will guide you through the installation step. When you click Launch, Jupyter Notebook will load up in your default web browser. Now, before we can start writing some code, let's take a look at what happens behind the web browser to run our code. This diagram from the Jupyter project documentation shows the relationship between the Notebook server and the code files. The Notebook server saves and loads the changes you make within the Notebook file. The kernel executes your code that is sent from the Notebook server. Python will work with the default kernel for Jupyter, but you can install other kernels if you want to run R code, Julia code, or MATLAB. The notebook file is where the Python code is saved and will have an extension of python.py or the IPython notebook extension. So this section will show you how to read a CSV file from the same directory as your notebook file. You can complete this section with any CSV file, but I'm going to use the Titanic training dataset from the Kaggle website. So I chose the Titanic training dataset because there's lots of other online videos and resources that you can use to transform your dataset. From the web browser, just go to Google, and we're going to search for Kaggle Titanic. Okay, and from here, I'm going to go to the link for train.csv. If I scroll down, I can see from the data dictionary I've got 10 different columns, or with data science we call that features. And scrolling a little further, I can see the train.csv. There's a link there to download our data. Now that the download is complete, I'm going to go back into Jupyter Notebook. And along the top there, I can see the upload icon. Just going to navigate to the directory. Now I saved it directly into downloads. I'm going to click train and click open. I'm just going to leave it called train.csv. Click upload. So now that train.csv file is loaded into our Jupyter Notebook directory. So now let's start a new notebook file. So under new, we'll click Python 3 to start that notebook. And I'm going to just give it a name now. We'll call it reading CSV files with pandas. Rename. And I'm just going to click into that first data cell. So as a best practice, usually the first code cell is where you're going to want to load all of your different external libraries. Now for us, we're only going to just deal with the pandas library to import to read our CSV file. So to do this, we're going to type import pandas, and we're going to rename this library as PD, just to make it easier when we run our code later. In the second code cell, let's go to the documentation. And we'll go to the documentation for pandas. So we'll say pandas, read CSV. And we'll just grab that documentation. So it's usually a good idea to go through the documentation. Can kind of tell you about the different parameters that you can call within the function. and usually there's examples as well. So just going to copy this link. Go back into our file, just write a comment saying read CSV files into a data frame, and we'll just have the link there. And let's just go back into the documentation. We'll scroll down to the bottom. So it kind of shows us there, we've got an example of how what we're gonna type to write that in our Jupyter Notebook file. Okay, so let's do that. So PD, you're calling PD, and read underscore CSV, and our file name was train.csv. Now we're just going to put dot slash because that's basically, since the file is actually located in the same directory, we just have to put the dot slash. Otherwise, we could add the full directory to where to go find that file. Okay, and then we'll just run that. Okay, so we can see the output. Oh, now from the data dictionary we saw 10 rows, but passenger ID and the name column, those were not mentioned at the time. Now that we have our data imported, let's just we're just going to assign this equals, and we're going to assign it into a variable. Just call it df for data frame, and since we're going to call, we can see here it's actually from row 0 to row 4. Then it's got some dots, and it looks like it goes all the way down to row 890. Now, if you only wanted to view the first few rows at the top of the data frame, there is a function called head. And when you run that function, by default, it'll actually show you the first 5 rows. Now, you could change that and by setting the n value to say something like 10, and that'll print that out. As well, so head, useful to see the top of the data file, and if you want to see the bottom of the data file, it's tail, and that shows you the last few rows in your data set. So from Jupyter Notebook, we can see that one of our notebook files is still running, showing the green instead of gray for the icon. Now, another way that we can see that is if we go up to the Running tab. This will list all the notebook files that are currently running. So if we go back, I'm just going to double click and launch that file again. So again, so we got run pandas, and we can see the tail, but let's just switch this back to head. Okay, so again, that shows the first 5 rows, so row 0 through 4 of our data frame. Now, another type of way of filtering out your data is called label-based filtering. So let's just write a comment here, label-based filtering. And let's just go find that URL, just in case we need it. Okay, so if we call the data frame, we'll call that label function. And with this, we could actually write the head function in exactly the same way. So what we'll have to do is we would pass the rows first. So we want to go from row 0 up until the one labeled number 4, which is our 5th row. And then as far as columns, we want to go from the passenger ID column and stop at the last one, which was what, embarked, embarked. Okay, and then we can just shift enter to run that. So we'll see we got the same output as we had for the head function. Now, with Python, if you leave a value blank associated with the colons, it'll just assume you want the first value if it's before the colon, and it'll assume you want the last value if it's after the colon. So again, we could write this like this, and we're still getting the same information output. So now another useful function is actually called the shape function. So this will actually tell you the number of rows that you have as well as the number of columns. So for example, we could say take that data and we could, let's just assign that to 2 different values. And then let's just print that out. So we're going to say data. Okay, and Shift Enter. Now, when you're looking at the data frame, you might have noticed the nan values. So what those are is if you have some missing values in your data, it'll show up as not a number or nan. Now let's actually take that and we'll filter out. So if we were to go and look at the first 5 rows and say let's just look at cabin, we can see that in the first 5 rows of data, we are getting nan values. Now, a useful way to look at that is we've got a function called isNull, and when you run that, you can actually, it does like a binary check to say, is this true or is this not true? So is it false, 0, or is it true, 1? And from that, you're actually able to say, you could actually sum up and find out how many, null values do you have in your data. So it looks like we're getting 3. Now that's not the full column, that'll only be 3 of the first 5 rows. So if we wanted to check out how much data is missing in the whole column, we can just go from there. So we've got, cabin actually looks like we've got a lot of missing data. And, we could go and let's run this again. Let's check another column. We got here age. So we got some missing data with age. Let's see what else do we got here? So let's check fair. See if we've got any missing data in fair. Okay, so it looks like fair is a pretty good data set here. Now, as well, there are other math functions that you can run on your data. So you could run, say, max, like what's the maximum value in the fair column? What's the minimum? Can you get an average? Now, if you were trying to do this on something like the age column, it'll still give you an average. It's just kind of exclude any missing data. So it's always a good idea to go through and check to see if you have any null values first, because that might actually affect your results. So let's just write that. So in the last section here, what we're going to do is we're going to import a different library, and we're going to just show you how to create a histogram based on that data. So next we're going to want to normalize our fair column, but we should plot it first just to see the type of curve we're going to get. So let's actually just save, make a new copy of this. So we'll call that, let's see, plotting with matplotlib. And so yeah, we're actually going to import a new library called matplotlib, and then we'll kind of create a histogram using that. So I'm using matplotlib. It's one of the older plotting libraries, but it is still commonly used. There are lots of different plotting libraries that you can use. I'm just going to use this one. Okay, so if we go up to the top, as a best practice, we're just going to want to make sure we do that import in the very first cell. Okay, so let's just go to Google. It's matplotlib Python. We see in the first link there, that's to the documentation. On the right side, we see we got the cheat sheets. Okay, let's click that. Okay, look at quick start, import. Okay, so import matplotlib.pyplot at plt. I'm just going to copy this. Okay, so what was that? Import matplotlib.pyplot as plt. Okay, and let's run that. Okay, that looks like it ran fine. And we'll scroll to the bottom here. Just going to add a comment. Create of the fair column with matplotlib. And we'll just add the cheat sheet in. Okay, so let's go back to the cheat sheet actually and see. Just looking for histogram. I see, okay, so in the advanced plots, looks like it's HIST, and then I just have to pass my variable, so my X value. Okay, so just beforehand, let's just check to make sure we've got the fair value. Okay, so it looks like we're getting that. So 7.25, 71.28 as the first two values. 7.25, 71.28. Okay, we're good there. So let's do that again. Fair. So that's going to be our X value. And we said HIST, I guess we got to call it plot dot hist. And we'll just not worry about the bin size for right now. We'll just hit Shift Enter. Get rid of that dot. And here we go. And we can see, so it looks like we're getting a right skewed data set. So we don't have a normal distribution of data. It does look like we have at least one of the z values that, or one of the values that'll actually quite high. So someone paying almost upwards of 500 or more. I think we knew that anyway because we were saying, let's just check that again. Fair. We'll do that max. Yeah, so we had that 512, which was our max value. So yeah, so that's just kind of a way to take a look at our data. So we know we don't have normal data, but we can still create some z-scores based on this data set. So we'll do that next. Let's save a different notebook file. So file, save as. Let's call this one creating z-scores, and then enter to save. So let's just kind of add a comment here. So we know we don't have a normal distribution, but we do know the formula for that is, you take the value and you divide by the mean value, and then you take all of that and you divide by the standard deviation. So, these are a lot of just standard math terms, so we can actually create the z-scores just using, we don't have to import any specific libraries or anything like that. So we could do it that way. So let's start that again. So let's go df. Let's grab the fair column. Okay, we see that there. We're good there. And so we'll take that, and let's just for simplicity's sakes, let's just assign it into a new value, our new variable called x, and then let's just output just the first few rows. So yeah, there we go. So now, so this is just to simplify things. So instead of having to call dfFair every time, we'll just call x dot when we want to run any specific math functions on top of it. So okay, so I guess we can actually so for example, like if we wanted to run x shape, it's 891 comma blank, because basically we've only got the one row or one column and 891 rows, which is good because that's kind of what we saw before. So that's good. And so yeah, let's do the normal distribution. So normal distribution would be what? So let's take that x value, and we're going to subtract the mean of that value. And then we're going to take all of that, and then we're going to divide it by the standard deviation. Okay, so that's basically how we do the your z-score. But before we do that, let's actually just let's just check a few things first. So what did we say the mean was? Okay, so you got a mean value of 32, and what was the standard deviation? Standard deviation is 49, so basically like 50. So if we were one standard deviation above the mean, we're looking at something like 50, 80, so 82. So if someone was paying $82 for their fare, they'd be about one standard deviation above the normal. So let's just go in and run the head again. So 71, that's kind of see here, that's 71 is about 0.78. Let's just check a few more values. Let's just do 50 and see if we can find anything that actually is much closer to that 80 value. Now we see one that's 263. Here we go, number 34. So let's say 34. So we know that, oh wait, sorry, not 35. Yeah, so we know the 35th value is actually 82. So instead of this, let's just back into, let's actually just assign all this x underscore, we'll call that, let's call it fare underscore z-score. So we'll run that column, and then here fare underscore z-score. Oh, forgot my E. Fare underscore z-score. Yeah, so we can see that where we had a fare of 82, looks like the z-score is 1. So it looks like that calculated fine. So yeah, so I would say, so basically right now what we have is this new value called fare underscore z-score. That is going to be our z-score of the fare value. So now what we can do is we can take this, so we can take that, which goes all the way down to what, 891 values, and we can assign it as a new column inside of our data set. Now we can call it anything we want. I mean, we might as well just call it like fare underscore z-score. And I'll just say I used Python to do it, and shift enter. So now that new z-score we created, that's a brand new column, and we actually just added it at the very end of our data frame. And we can check that by checking the head value. So yeah, we can see at the very end there, we've got fare underscore z-score underscore Python, just to say that we imported it in there. Now that was a bit of a manual process in order to make the z-score just using standard Python. I mean, lucky for us, an alternative way to do that is we can pull in a library to automatically generate the z-scores. So from that, we can actually use one from scikit-learn, and it's just called the standard scaler. So to do that, let's just go and we'll look up standard scaler. From the documentation there, we can see, so we can see the formula there, which is take the value minus the mean, and then divide the standard deviation based on that. So basically, this is exactly the same thing that we just did manually doing it. So let's just go down to the example, and from here we can see this is the way that we're going to import in the standard scaler. So to do that, best practice, let's go to the top, and from here, so basically from sklearn, so scikit-learn, we're going to pull in something called preprocessing, and we're going to import that model or that function called standard scaler. So let's run that now. Okay, so that's run. Then we'll go back down to the bottom. Now let's see how they did that. Okay, so they basically pulled, we've already got our own data field. So we're going to pull in standard scaler. Just going to call it scalar. And so they fit the data, and then they transform the data. So you could do it in two different steps, or there's also another one where you can actually just do it all at the same time, which is fit transform. So let's do that. We'll call it scalar dot fit transform. And the data we want to pull in was what? The data frame fair. And I want to close my circle bracket. So let's run that, see what we get. Okay, we got an error. Let's check the error. Okay, so it's basically saying what I had passed in was a 1D array when it really wanted a 2D array. So let's just hit the plus sign here. We'll just talk about the difference there. So what it's talking about. So if I was to take this fair column and do a shape, we can see I only have one dimensional. It's only one dimensional because it has 891 rows, or sorry, 891 rows, but there's actually no columns associated with that. So to do that, what I'd have to do is just add these extra square brackets around. So let's just do that. So if I do that, you can kind of see now it says I've got that one dimension. I've got that. It's now two-dimensional. So here I'll show you the difference. So this basically, when you look at it, it's just showing you the data basically as like a big list. But if I have two square brackets, it kind of looks more like that data frame we were looking at before, right? Where you've got labels on this side and you got a label for fair there as well. So that's the difference between a 1D array and a 2D array. So let's see. Just write this. As a 1D array and fair as a 2D array. Okay, and I'm just gonna, if you hit Control and then question mark, that actually just kind of comments out whatever you have highlighted. It's just kind of a good tip. Okay, so what we wanted to do was, let's just take that 2D array and we'll put it in here. Okay, so now it's a 2D array. Now, it is an array, but we want to convert that back into a data frame. So that was pandas. So data frame. Now let's just call this X array. So we're just going to assign that into that. And then we're just going to, basically it's just a conversion. We're just going to convert this into the array here. Oh, sorry, not date frame. Okay, so now we see it's got all this data here. So basically it's a 2D array, right? So now we can take this and we can assign it. We can bring it back into our original data frame. So similar to how we did that last time. What did we call it? We called it something with a z-score, right? Oh, here it is. Yeah. So instead of, so we'll do the same thing. Bring this in here, except instead of Python, we use standard scalar. Okay, and now we can check that. Let's just do the head. Yeah, so see, the second to last column was when we did it with just using the standard Python library. This one uses that standard scalar, but we had to convert it to a 2D, and then we had to convert it from an array back into a data frame. So, I mean, I guess it really depends on what you find easier. So just cleaning this up. So we'll say using standard scalar to create z-score for fair column. And we'll say this one was, oh, well, that's the URL. This was convert into a 2D array. And this was convert 2D array into a pandas data frame. Okay. And so yeah, that's obviously two different ways. I mean, depends on which you like. You know, you can either do the math yourself, or you can import in a library and then just kind of do your z-scores that way. So you know, that's two different ways to do that. So in the next video, we'll make some z-scores, but we'll use some random data instead of the Titanic data set. So yeah, so thanks for watching.